Finding an angle that's coterminal, there's not just one right answer. So they're asking us to restrict it to be between 0 and 360 degrees. When I start out with theta equal to 1,230 degrees, that's bigger than 360. So I need to reduce it by as many 360s as possible to get it down between 0 and 360. Because remember, coterminal angles are off by 360 degrees. So I can just subtract 360 a bunch of times and see once I get into the range that I want. 1230 minus 360 is 870. Minus 360 is 510. Minus 360 is 150. 150 degrees is coterminal to 1,230 degrees. Another way that you could do it is you could divide and kind of estimate how many multiples of 360 are there. 360, 3 goes into 12 4 times, but that's going to be a little too big. So 3 times 0, 3 times 6, 3 times 3, and then I have 150 left over. The leftover is my coterminal angle. For question B, I'm negative and I need to be positive, so I need to add 360 degrees rather than take that away. And 360 minus 315, or negative 315 plus 360 is 45 degrees. And so if you were to graph these, 45 degrees is this way, and negative 315 degrees is this way. And for part A, if you were to graph that, 1230 is 1, 2, 3 rotations over, and 150 is just 1. The same thing is true for when we're restricting an angle between 0 and 2 pi. That's the same thing as restricting from 0 to 360 degrees. We're just dealing in radians rather than degrees. So I have negative pi over 8. Negative pi over 8 looks like this. Go down. And so what I'm going to do is I'm going to add 2 pi to that to find the difference. That's 15 pi over 8, and that is less than 2 pi, so I'm in the range that I need to be. 19 pi over 4, that is too large. So in this case, I need to take away 2 pi as many times, just like I did with the 1230, to figure out and get in the range between 0 and 2 pi. So 2 pi and fourths is going to be 8 fourths. 8 pi over 4 is the same thing as 2 pi. So I'm going to take 19 pi over 4 minus 8 pi over 4. That's going to give me 11 pi over 4. Now, that is also too big because remember, 8 pi over 4 is the maximum that we can be. So I'm going to take another 8 pi over 4 away, and that's going to leave me with 3 pi over 4. So that angle is here. Okay. I want to find the arc length made by an angle of 220 degrees on a circle of radius 9. So they're telling me the radius is 9 inches and theta is 220 degrees. I know that the formula for arc length is radius times theta, so it would be cool if I could just do 9 times 220. But the important thing about an arc length is that it needs to be in radians. So in order to do this problem, I need to take 220 degrees and I need to convert it to radians, which is multiplying by pi over 180 degrees. I can divide out a 10, and 2 goes into 22 11 times, and 2 goes into 18 9 times. That converts to 11 pi over 9 in radians. So now I can find the arc length by taking 9 for the radius and 11 pi over 9 for theta, and conveniently the 9's cancel, and this arc length is 11 pi. 11 pi is roughly 34.6 inches here. Because remember, it's a length, so we're not working in degrees, we're working in lengths here. Lincoln, Nebraska is located 40 degrees, 40.8 degrees north, 96.7 degrees west, and Dallas is located 32.8 degrees north, 96.7 degrees west. So they both have the same um, longitudes, and they're north-south of each other. So you've got Lincoln, Nebraska up here, and then you've got Dallas, Texas down here. So we want to, using the difference in latitudes, which is going to be the north here, approximate the distance between the cities, assuming that the radius of the Earth is 3,960 degrees. So we're basically just trying to figure out what this distance is here. Obviously, it's not a straight line. The Earth is round. And so when we're looking at a globe, we're really talking about some sort of portion here. And it's just straight up and down on that sector because we don't have to deviate east or west. And so when we are approximating this distance, we are using the arc length formula. We have that r times theta, where the radius is 3,960. Our theta, again, this is degrees, so we need to find the difference between 40.8 and 32.8. That's 8 degrees. But I need to convert that into radians, so we're going to multiply that by pi over 180 degrees. 4 goes into 8 twice. 4 goes into 180 degrees 45 times. So that's going to convert to 2 pi over 45. Multiplying this out, we get about 552.9, or rounding to the nearest mile, 553 miles when you take 3,960 times 2 pi over 45. This is a good point to talk about calculators. I use a Texas Instruments TI 84, which has a pi button, and anytime I am multiplying by pi, use the pi button. I don't ever approximate 3.14 because every time you approximate, you are decreasing your accuracy. Sprinkler rotates through an angle of 120 degrees. Let's just draw this out. So I've got my sprinkler. And sprays water a distance of 30 feet. Find the amount that's watered. That 30 feet is in my radius and 120 degrees is my angle. So I'm trying to find the area because I want to find the amount that's watered. I want to know all of that. That's area. Remember that the area is 1/2 the radius squared times theta. And again, theta has to be in radians. That means I need to take that 120 degrees and multiply it by pi over 180 degrees. And 120 over 180 simplifies nicely to 2 pi over 3, as 6 goes into 12 twice and 6 goes into 18 3 times. So that's 2 pi over 3. The area is 1/2 30 squared times 2 pi over 3, or half of 900 times 2 pi over 3. The 2's cancel, 3 goes into 900 300 times. So the area is 300 pi, which is, rounding to the nearest whole unit, roughly 942 feet squared. And that is all the skill practice we have for this section.